All right, welcome to section 5.1, which is about polynomials. Actually, the whole next chapter is about polynomials. And so in this first one, we're just going to learn some basics. So our first objective for your notes here is to learn like vocabulary associated with polynomials. Oftentimes when we're learning a new topic, I'll say words like trinomial and quartic and all these other weird words. And so it's good to know what those words mean so that we're all on the same page when we're using the different vocab. So the very first thing we're going to do is like, what is a polynomial? And so I think oftentimes a good way to learn is to look at these examples. And so you can see the ones on the left are polynomials, the ones on the right are not. If you have any guess, see if you can pause the video and use your detective skills to figure out what is it that these have that the other ones don't. All right, so hopefully you got a chance to think about it. But the definition is their expressions. These are all expressions, but they could have an equal sign and be equations where the exponents are numbers. So if you look here, this exponent is a 2 and a 1 and a 4, and then this is just to the first power. Okay, so the ones on the right end up not being polynomials because they have x. This one has x as an exponent. Same thing here, and then anything with a root like that is also not going to be a polynomial, right? So maybe you could add your own examples of polynomials here. Maybe pause the video and do that quick. Make sure you got it. Just want to point out polynomials can have only one term, so just like 7x by itself, that's a polynomial with a power of 1. They could have a whole bunch of terms, 5, 6 terms, right? The things that are separated by plus and minus, those are called terms, right? So that's what a polynomial is, all right? And then I think what's up next is how you identify them. And so here's like a bunch of polynomial examples again. And one of the ways you can name them is by their highest exponent. So as an example, like to the first power, we've talked about that a bunch. That's called linear. Last chapter we did quadratics, which have a highest exponent of 2. It always goes by the highest. So this one technically has a linear part 2 to the first, but its highest exponent is 2, meaning it's quadratic. Third power is called cubic. Fourth is quartic, and fifth is quintic. Okay, so you might want to add this. I always forget to put this on the note sheet. So if you have the note sheet, you could just add a little sixth one here. And after 6, there is no special name. They just call it like a 6th degree or a 7th degree or whatever the exponent is. Okay, and if we do an example of a 6th degree, like x to the 6th plus 2x to the 5th minus 7 or something, right? And that would be a example of a 6th degree polynomial. Right, so that's one way to name them is by their highest exponent. All right, and then the other way to name them is by how many terms they have. So the terms are just the parts that are separated by plus or minuses. So like this one just has 1 term, this one has 2 parts, this one has 3 parts, this one has 1, 2, 3, 4, 5. Okay, so there's a name for 1, 2, 3, and 4, and I want to see if you can fill in as many of these as you can. Your hint is that they all end in nomial, right? We're learning about polynomials, so all the names here end with nomial. So pause the video and see if you can come up with some of these names. Okay, so one, maybe you've heard mono means one, like monotheistic means one God. So monomial is for just one part. 2 is like bicycle, or bifocals means 2. So in this case, it's a binomial. 3 is like a tricycle. So this one's a trinomial. Okay, and then for 4 or more, there is no special name. So we just use the general name, which is polynomial. And poly kind of means many. So it makes sense that, this one has many, many terms. The kind of confusing part about this is polynomial is the general name. So all of these actually fall within the world of polynomial. So if I can draw a picture here, this is going to be a poor picture, but if I have all the polynomials out there, then like a monomial is a specific type of polynomial with one term, right? Monomial, binomial. Okay, and same thing with like a cubic, right? A third power. that's a special type of polynomial. So polynomial is kind of the very, very general name, and then everything else falls inside of it. So when you name it by its number of terms, if it has more than 4, we just use the word many, many terms, and we don't have any special name after that. All right, next thing to fill in on your note sheet, or if you don't have a note sheet, you can just take notes in your notebook. But standard form is when you write the exponents in descending order. All right. So these say write it in standard form and then classify it. So again, I'd pause the video and see if you can make sense of this definition and get this in standard form. Okay, so here we go. So you put the x to the 6th part first, then the x cubed part. X squared is the next highest exponent. And then the last number is oftentimes called a constant, because that does not change with the value of x. All the other terms depend on what x is, but 1 is always 1. So the part without x that is often called a constant. The other thing you might want to label here is these numbers in front of x are sometimes called coefficients. And so this first one we'll refer to as the leading coefficient. You'll hear that a little bit in this chapter. It's not a super important thing, but you might hear it. It's called leading coefficient. All right, for the names for this one, it's got 4 terms, so we would just use the general name of polynomial. And then by exponent, its highest power is 6, and there's no special name, so it's just called 6th degree. All right, second example. Again, try this if you haven't already. But putting it in order, highest exponent first, and then constant last. And then this would be a cubic because its highest power is 3. And it's got 3 terms, so that's called a trinomial. All right. A couple more examples like that, especially this last one. If you feel like you got it, I wouldn't worry too much, but definitely try this last one because that one's a little bit different. All right, these would actually be equations, by the way, because there's equal signs in them, but they're just polynomial equations instead of expressions. And so putting this one in order, the x to the 5th would be first, then the x cubed, and then the constant last. Okay, and this one would be a quintic for the 5th power, and polynomial because it has many terms, 4 terms. Once you get 4 terms, there's no special name. Sorry for the poor handwriting. Next one, writing it in standard form, you'd put the x to the first, and then the 5 constant last. Okay, and then the 2 names, these are really important names to know actually. Binomial, you'll hear me say that a whole bunch. That just means 2 terms, 2 parts. And first degree is linear, which hopefully you already know. All right, last one, they do this from time to time to make it a little tricky, is these look like linear terms, but it's actually not considered linear, because if you simplify it a little bit by FOIL, you'll get an x squared. Okay, so before you do anything else, you should actually FOIL it out, do the FOIL steps, multiply all the different parts together. That's what it means when you have 2 things next to each other like that. Okay, and now that we've multiplied it out, now we can identify it. So now it is a quadratic, because its highest power is 2, which we studied last chapter. And it's got 3 terms, so it's a trinomial. And that quadratic weird is weird because you think it'd mean 4, but it actually just means x squared. Okay, so next up, the second part of this objective, kind of a minor objective because we're going to do this more later in the chapter, but we want to just get the basics of graphing a polynomial. All right, and why I think this is not that important is we're not actually going to do a table of points or anything like I might say in the book. We are just going to use our calculator. All right. You can use, at this point in math, you can use graphing calculators. You can use them on the ACT and the MCA and all the tests and stuff. So we're going to just use them in this class. So basically you need a graphing calculator or that Desmos site if you don't have access to a graphing calculator. Use Desmos. And basically to graph, just type it in and get what you see. So one of the kind of interesting things about the graph, at least I find this interesting, is x to the first is just a straight line. And then x squared adds like a single turn or curve. I think that's what it means by turning points. Okay, and then an x cubed, it has two squiggles. And you could probably guess at this point, x to the fourth is just going to add another squiggle to our situation. Okay, and so I think that's kind of a cool pattern that it's one more twist each time. So we know that this one is going to look like this kind of squiggle, close to the squiggle shape, right? So let's just get out Mr. Calculator or Mrs. Calculator and go to y equals here, clear anything out, and I'm just going to type 3x minus x little hat thing right here to get an exponent of 3. Make sure I got the right one, and then I'm just going to hit graph. Okay, and all I'm going to do is sketch that picture. Okay, so it's going to be going through 0, 0, and I'm not going to worry about the rest of the points. I'm going to have a hard time sketching on my little pad here, but that's actually not too bad. Hopefully you get the idea, and that's all we're going to do with the graph is just graph on our calculator, and then we're going to talk about the end behavior here. That is on the test, so we'll talk about that here in a second. All right, one more for you to graph again. Pause it, do it on your calculator, see what you get. All right, hopefully you've had a chance to try it. So 2x little hat thing cubed minus 4x, and graph. Okay, and it's another x cubed squiggle, kind of like the last one. So it's going to be kind of like the last one, but a little bit different. Looks like it's still going through 0, 0. All right, so we just draw the squiggle. And then the final kind of part of this lesson is we want to talk about something called like the end behavior. And that's just like what happens on the end of the graph, right? So we were starting to talk about those pictures I talked about here, right? These are what the pictures look like. And so an x cubed will always be like down on one end and up on the other end, right? And so it also depends on if it's negative in front. So this was a negative x cubed, so it was the reverse of the picture I drew here, meaning it is end behavior is up on this side and down on this side. So we call that end behavior of up and down, right? And then the positive x cubed, so this one is an x cubed, but it's positive, has a reverse of that. It has it down on this side and up on the right-hand side. Okay, so in our investigation of graphs, we just want to talk about the end behavior right now. And there's really 4 different things. You can be up on both ends, down on both ends, and then down up or up down. Okay, and really there's 2 things that drive it. The highest exponent, and then is it negative or positive in front of that. So these even ones, so this one our highest exponent's 4, here our highest exponent's 2, they're either going to be like both up or both down. And if it is positive in front, they're both up. And if it's negative in front, they're both down. Okay, and then an odd one will be one of each. So these are x cubed, or the highest exponent is cubed. Always look at the highest exponent. And this one's positive, so it's down up. And then if it's negative, it just flips the shape. It kind of just flips the shape over. And then you get up down for the end behavior. Okay, so I want to make a little chart here, and I would recommend filling this in your notes. Please know that you can always just graph and look at the end behavior, but you can also use this little chart, which I'm going to add here quick because I'm running out of time. So here are your possibilities. If you have an even highest exponent, like an x squared or x to the fourth, and it's positive in front, you can think of like a positive x squared. It's going to be up and up. So as an example, that's a positive x squared. Okay, and if it's negative, so like a negative x squared or negative x to the fourth, would be down and down. So it's going to look like that, down on both sides. Okay, and here's the odd ones real quick. If it's odd positive, down and up. If it's odd negative, it'll be up and down, and that's true x cubed.